Today we will see how to do some programs, simple programs using pointers as well as pointer arithmetic. So the first program is to find the sum of two numbers using pointers. So you're having two variables x and y and sum to find the sum of two numbers, to store the sum of two numbers, and then you're having two pointers xp and yp. So pointers means the declaration statement is star xp and star yp. So like usual programs, you're reading the values of x and y. Then what you have to do is assign the address of x to xp, assign the address of y to yp. So that's the statement, xp equal to ampersand x, yp equal to ampersand y. And now to get the value using the pointer xp, you're using the indirection operator, that is star. So star xp will be giving you the value at x and star yp will be giving the value at y. So star xp plus star yp will give you the sum, and that you are assigning it to the variable sum and printing the sum. See the output over there. Enter value of x, you have entered it as 4. Enter the value of y, you have entered it 5. Then you are adding the two values 4 and 5 and it is assigned to sum, that is 9. Next program is to find the greatest of two numbers. So declaration is same as the previous program. You're having to read two numbers. So you're having the values x and y. You're having pointers xp and yp. You're reading the values for x and y. Then xp you're assigning the address of x. Yp you're assigning the address of y. Now you have to compare the two values. So star xp greater than star yp. If the condition is true, the value at xp is greater. So you, instead of writing x, what you're writing over there? Star xp. Else y is greater. So how you will get the value at y? Star yp. All the others are same, like the usual programs that you're doing without pointers. Next program is to swap two variables using pointers. You're having two variables x and y initialized as 10 and 20. Then you're having temporary variable that allows you to swap two variables. Then you're having two pointers a and b. Now before swapping, you have printed the values x and y. You will get the output as, before swapping, value of x is 10, value of y equal to 20. Now you are assigning address of x to a, address of y to b. Now temp equal to star a. A is having the address of x. So star a will give you the value at x. Temp equal to x. Star a equal to star b. Value at b, that is y, equal to value at a, that is x equal to y. That is the statement over there. Instead of writing x equal to y, what you are writing? Star a equal to star b. Now star b equal to temp. So value at y will be equal to temp. Now x will be having the value 20 and y will be having the value 10. So after swapping, when you're printing x and y, you will get it as 20 and 10. It's the same program like how you're writing temp equal to x, x equal to y, y equal to temp. Those three statements have been written in terms of their address. Temp equal to x is the first statement. So what is x? Star a. Second statement is x equal to y. So star a equal to star b. Third statement, y equal to temp. It is written as star b equal to temp. See the output. So output is, before swapping, you're having x equal to 10 and y equal to 20. After swapping, you're having the value of x equal to 20 and y equal to 10. You can do and check the program. Next program is to find the reverse of a number using pointers. So when you want to reverse a number, the input is one number. Okay, and for storing that number, you require one pointer. Here, number, you are reading the number as num, and then you are assigning its address to PTR. PTR equal to ampersand num. The usual program, what do you do? How to reverse a number? Given number, you are checking to get the last digit. For reversing, get the last digit, multiply it by 10, then again get the last digit, add it to the previous number. So that is done inside a loop, like how you are doing sum of digits. Okay, so PTR equal to ampersand num. The address of num is assigned to PTR. As in the usual program, wherever num comes, you simply have to write it as star PTR. So while star PTR not equal to 0, what are you doing? Digit equal to, that is you are getting the last digit. Star PTR mode 10. So you get the remainder when dividing by 10. That is a mode operator. You got the digit. Now initially reverse equal to 0. 0 into 10 plus the digit. So it becomes as the last digit. Then PTR equal to PTR by 10. Divide the number. You lose the last digit. So suppose you are having an example 345. The last digit is 5. Now reverse will be equal to 5. When you are dividing, the new number will be equal to 34. Is 34 equal to 0? No. Loop continues. 34 more 10. What are you getting? 4. Now initially reverse was 5. 5 into 10, 50. 50 plus 4, 54. So now reverse is 54. Star PTR was 34. 34 by 10, you're getting 3. So now PTR equal to 3. Is PTR equal to, star PTR equal to 0? No. Again get the last digit. Star PTR is 3. 3 more 10, 3. Reverse digit was 54. 54 into 10, 540. 540 plus 3. You're getting 543. Now PTR equal to 3. 3 by 10, it is 0. So while coming back to the while loop, PTR, star PTR will be equal to 0. So the loop stops and you're printing the value of reverse as 543. Hope it's clear. Next program is to find the factorial of a number. So enter the number n. Address of n is assigned to the pointer PTR. PTR equal to address of n. Wherever n is present, you simply substitute the value star PTR. So how do you find the factorial of a number? Using a for loop. For I equal to 1. You don't start with 0, else the whole factorial will become 0. So you start with 1. I equal to 1. It was I less than n. So instead of n, what you're writing? Star PTR. Value at PTR. That is actually the value at n. So star PTR I plus plus. F equal to F star I. So the loop continues from 1 to n. You'll get the factorial in F and you're printing the factorial. So in the output, enter the limit, that is 5. Factorial of 5 is 120. Now we'll check out some arithmetic operations onto pointers. Here we are having two integers x and y. X equal to 10 and y equal to 20. We are having two pointers star m and star n. You're storing the address of x to m equal to ampersand x, and you're storing the address of y to n equal to ampersand of y. Sum equal to star m plus star y. What do you get? The value at m plus the value at n. So what is the value at m? 10. Value at n, 20. 10 plus 20 equal to 30. So the output would be 30. In the next statement, we have written x equal to star m plus 110. What is star m? Value at x, that is 10. 10 plus 110, the output would be 120. Next is division star m by star n. There's a space in between the division operator and the star. That is a must. So here you will get star m, the value is 120. 120 by 20, the output would be 6. Next statement, can you see? You have written the division operator and the star together. You will get a wrong error message. Why? Because that is considered as the command line for the C programming. Next we will see operations on pointers. It allows pointers, you can do addition and subtraction. You cannot do multiplication and division. The reason is you can add one address to another address, or you can subtract one address from another address, but it should not go negative. But you cannot multiply one address with another address, or you cannot divide one address by another address. Now when you're incrementing a pointer by a value 1, okay, it increments depending upon the data type. Because when you're allocating memory for integer, suppose the address is 1000 that you are allocating, the memory address. When you are allocating it for integer variable, how many bytes are allocated? 2 bytes are allocated, that is 1001 and 1002. Both are reserved for the variable. Like in the example, see, int a equal to 10. Suppose the memory address of a is 5000. 5000 and 5001. Both are allocated for which variable? A. So, whenever you are incrementing the address, it increments by a scale factor, and the scale factor depends upon the data type. If it is an integer data type, it will be incremented by 2 address. If it is a floating data type, it will be incremented by a factor 4. So, suppose it was float a equal to 10, and the starting address of a is 5000. 5000, 5001, 5002, 5003. All the 4 bytes are allocated for which variable? A. So when you're incrementing the pointer, it becomes from 5000, it increments to 5004. That is, it increments by a scale factor of 4 depending upon the data type. Now if it's a character variable, scale factor is only 1 because only 1 byte is allocated for character. So here you're having in this example int a equal to 10 and star p1. Star p1 is having the address of a, ampersand of a. And the next statement, p2 equal to p1 plus 1. So address of p1 is incremented by 1, means it will be incremented by 2. Suppose a is stored at the location 3000. What is the value of p2? 3002. Now see each of the printf statements. Printf value of star p. What is printed? The value of a. What is value of a? 10. So you will get the value 10. Printf value of p1. Simply you are printing p1 without any star. So it will print the address of p1. That is address of a, that is 3000. Next statement, p1 plus 1. It will become 3002 because 2 bytes are allocated for the variable a. Next statement, p1 plus 2. It will become 3004. p1 plus 3 will become 3006. So each is getting multiplied by a factor of 2. So in the first case 2 bytes, second case 4 bytes are increased, third case 6 bytes are increased. Now in this, how will you predict the output? Check the values. Star p is a pointer, num is a value. You are assigning p to the address of num. Next statement, star p equal to 100. Value at that particular address. Whom is p pointing to? Num. Value at there equal to 100. So num is automatically assigned as 100. So when you're printing num, 100 is printed. Next statement, star p plus plus. Star p means the value at that address, that is 100 plus plus, so it becomes 101. Num becomes 101. Pointer is not changed. Okay, if you write p plus plus, the pointer is changed. If you're writing star p plus plus, the value at that particular address is incremented. Value at num is incremented by 1. Num equal to 100, and incrementing by 1, 101. Next statement, star p minus minus. Star p is value at num. What is the value at 1? 101. 101 minus 1, it becomes 100. So when you're printing num, it becomes 100. Only if you're writing p plus plus, the address is incremented by a scale factor of 2. See the difference there? Here you're writing star p plus plus, the value at that address is incremented. If you're changing the address, only it is incremented or decremented by a scale factor, not when you're changing the value at that particular address.